Here's a quick video to go over a problem out of MyLab. It's section 11.2 MyLab homework. It's the sixth problem of the set, which is number 11 in the textbook in that section. And they're talking about a claim about the heights of fathers and their sons. If you look at the data comes to us as matched pairs. Each row is a father-son pair where the x value is the father's height and the y value is the son's height, and that's why we're in a matched pair scenario. So in that situation, what we're looking at is the difference of the value in each pair, and they tell us that here, saying that d for difference of the ith value is the x value minus the y value. And the claim that we're asked to test is, are sons taller than their fathers? So in other words, does this sample provide significant evidence that sons are taller than their fathers? Well, the sons were the y values. If the y value is bigger than the x value, then this expression, d, is negative. So the question is whether this sample produces evidence in favor of the alternate hypothesis that this value, x minus y, is negative. So the null hypothesis should be that the mean difference is 0, and the alternative hypothesis should be that that mean difference is negative. So what we need to do, if we follow this table on page 537 of the book, this is a t-test. It's t because essentially once we take the differences, we're talking about a single variable test, and we don't have the standard deviation of the population, so we need to use the t-distribution. And we're looking at this p-value approach here, so I need to compute the test statistic. I'm going to come back here and pull up the data set, which I have in MyLab already, in StatCrunch already. And I have the x values here and the y values here. What I need to do is compute the difference. So I'm going to go ahead and compute the difference from an expression. And I had already typed this in, so it shows it here. But basically, I got to take the title of this column, which is x, put it in quotations, minus the title of this column, which is y, with its name in quotations. Once I click compute, StatCrunch will create a new column. This is my D column. These values are my D values. So what I'm going to need in order to compute this test statistic is I'm going to need the standard deviation of those values and the number of those values and the mean. So I'm going to go through and look at summary statistics of columns, and I'm going to take the difference column. I'm going to want the count, the mean, the count, the mean, and the standard deviation. And when I compute that, it gives me these values. I have an Excel sheet over here just to keep me organized. So the count was 13. The standard deviation was I'm just going to copy this. I forgot to put in the mean. This is D bar. And that's here. So that's the mean value. And in order to compute this SE, which I've used to abbreviate standard error, that is this denominator. And that's coming essentially from the central limit theorem that the sampling distribution of means should be the standard deviation of the sample divided by the square root of the number of values. So I'm going to go ahead and type that in, equals that value divided by the square root of the number of values. And now, continuing to follow this textbook, this is just essentially the z-score. It's the observed mean difference minus the hypothesized mean difference. That's the coming from h0 divided by the standard error. So t is going to be d bar minus 0, I'm not going to write it, divided by the standard error. And somehow this did not recognize as a number. I'm not sure why. Let's try that again. This should have come out of this. Okay, now it worked. So that's my t value. I'm going to copy it. I'm going to check it here. and they want 2 decimal places. So that should just be 0.001. Okay. Once I have that, I'm able to compute the p-value. And since this is a left-tailed test, the book hints us there, the left-tailed test means I'm looking for a p-value to be the leftmost area. So I'm going to, again, go into StatCrunch, except this time I'm going to put up a t-distribution calculator. And degrees of freedom should be the number of matched pairs minus 1. And I'm looking for a p-value that's less than my observed statistic. A p-value for all random variable values that are less than my observed statistic. I'm going to go ahead and use the rounded value here and click compute. And that's the value I got. So the value that I had there coming out of the StatCrunch t-distribution calculator rounded to 3 decimal places was 0.504. And then the question is whether how to assess that p-value against the level of significance. And of course, we saw that was a huge p-value because the difference was really close to 0 anyway. So definitely that sample did not provide evidence in favor of this claim. In fact, it came out a little bit the opposite direction slightly. But certainly nothing we wouldn't expect due to natural random variation. So the question is, should the null hypothesis be rejected? And we would say we do not reject the null hypothesis because the p-value is, well, it's greater than the level of significance. So there is not sufficient evidence to conclude that sons are taller than their fathers at this significance level.